In this video, the enrichment video to Unit 3, Lesson 2, we are going to prove that the product rule is true. Remember that product rule says that if f of x is a of x times b of x, then the derivative f prime of x is ax times b prime of x plus bx times a prime of x. In my other video, I did a prime of x times bx first. I did it like this. For this part, I wrote a prime of x times bx. Of course, with multiplication, as commutative, you can multiply in either order, so it doesn't matter. So they're equivalent. Okay, so let's prove that this is true. Remember that the definition of the derivative, f prime of x, is the limit as h approaches 0, f of x plus h minus f of x over h. Well, if f of x is a of x times b of x, then f of x plus h has to equal a of x plus h times b of x plus h, and f of x is just a of x times b of x. So f prime of x, we know, is just the limit as h approaches 0, a of x plus h times b of x plus h minus a of x times b of x over h. Now, in order to prove this, we know that by the definition of derivative, I'm going to put this down here, a prime of x has to equal limit as h approaches 0, a of x plus h minus a of x over h, and b of the derivative of b prime of x has to equal limit as h goes to 0, b of x plus h minus b of x over h. We know these are true. So our goal is to be able to factor out this part, these two parts, from our expression. Okay. Now what I'm going to do is, we have two terms here. We have the a times x plus h. We have the a of x plus h times b of x plus h term. We have the negative ax times bx term. I'm going to separate them. So I have this term, and I have this term. I'm going to separate them, that's okay. And in between, I'm going to add and subtract the same term. That's okay because it's the same value. I'm going to subtract and add f of x plus h times gx. So we're going to minus, I said f of x plus h, it really should be a of x plus h times bx. So a of x plus h times bx. If I subtract it, I have to add the same thing, plus a of x plus h times bx. Okay. If they're the same terms, I can do that. But this lets us separate and factor out. Notice now that I have an a of x plus h term for these two. So that means that I can factor this out. And then the remaining part is this. Similarly, for the second term, I have a b of x here and here. So I can factor out a b of x. So factor out the b of x. And I have remaining a of x plus h minus a of x. Of course, the whole thing is as h goes to 0. So to summarize, right now we have as limit of h goes to 0 for the whole thing, I have two terms. The first term is a of x plus h times b of x plus h minus b of x over h. And the second term is plus b of x times a of x plus h minus a of x over h. Okay. But notice, right here, this, because we have limit as x goes to 0, it's just b prime of x. And this one is just a prime of x. So this gets us to, and also notice that, one more thing, notice that the limit as x goes to 0 of ax plus h is just equal to a of x, because x goes to 0. Because that's true, then as we evaluate the limits, this gives us, the limit is gone, we have evaluated the limit. So this gives us a of x times that part, which is b prime of x, plus b of x times this part, which is the a prime of x. And we have proven the product rule. That's it.